like if you wanted to spend some money on Google Cloud or whatever. But then they had it play against itself, and it just ended up getting insanely good. So GPT-3, that's a good question. Okay. More on this later. Homogeneous coordinates. Cool. After the vertex shader, the vertices are used to draw triangles. I'll say that's the most common. I'll say comma, the most common type of primitive. These triangles are rasterized into fragments and colored by the fragment shader. So then I'll put in a copy of the fragment shader. I once asked a GPT-3, which is taller, Mount Everest and a shoebox? Answered shoebox, the question borrowed from Scott Aronson. Okay. Interesting. Okay, so I'm going to say this fragment here simply, I'll say colors each fragment red. I'll say using RGB. Filling the RG and B and A channels of each fragment with 1, 0, 0, and 1 respectively. Yeah, this is output as a vector passed to the frag color variable. So even this, which is fairly straightforward, is actually glossing over a fair bit. Because if you're first looking at this, it's like, okay, what's this version 330? What's this in directive? You could maybe come up with vec3, vec4. What does GL position mean? I think it's fairly easy to use linting for comments. What do you mean by that? Do you mean like these diagnostics? Or what do you mean for comments? Okay, and so that's actually probably all. That is enough to draw your first triangle. This is a really basic GLSL. I think that'd be fairly straightforward to do. There's a bunch of grammar syntax spell check plugins. Oh, I actually don't know which ones. I just installed a bunch of them for the most part. For syntax, I'm using LSP. So NeoVim or NeoVim 0.5 has integrated language server protocol. And so I'm using that for Python. But for spell checking, I don't know, like why it doesn't like rasterize. Because it just doesn't know about that word. Okay, so after knowing how to draw a triangle, That's when you'll probably want to, the ones that comment on style like redundancy or use superfluous words. Interesting. I feel like at that point it might get, if I do the ones that comment on style like redundancy or use superfluous words. Interesting. I feel like at that point it might get, it might get a little bit annoying to me. If it's telling me like, use a more straightforward word for this. Like Grammarly, which gets memed super hard. It'll like check your grammar. It's pretty unobtrusive. Okay. I might end up trying something like that. Okay, so I should call this I don't know, shader basics. See? So I think I'm mostly gonna want the same sort of setup. I'll just want to have some variables with each of these things. Like a triangle was a good thing for drawing a triangle. Maybe this is where I could go into some of the full screen quad type stuff. For example, a fairly decent thing to get started on when you're learning shaders would be whichever one of those color things was spinning. Was that the simple inline full screen quad? Maybe? Nope, not that one. Was it named full screen quad? Nope, not that one. What was it? Named shader example, maybe? Inline shader example? Nope. Inline full screen quad. Great. So this one, I think would be a pretty cool thing to learn. This or the shaders look on pixel art. Yeah, they look really neat. One thing that's not that great about teaching this would be it doesn't teach you that much about the vertex shader. Okay, I think this would be a good example for the vertex shader, and I should come up with something to do for the fragment shader. I think that would make sense. Then the question would be, what should I come up with for the fragment for the vertex shader? I hope this one is relatively straightforward too. This was inline full screen quad. This one, yeah, this is fairly straightforward. That's okay. Is this all GPU? Yeah, this is running on the GPU, yeah. So this is just taking this, we're just taking the frag chord, dividing that by the resolution. This is bringing it to 1x1 space. Converting into polar coordinates. So you get an angle and a radius. And it's just passing the angle and the radius. I wonder why it's adding 2 pi? Or it's adding a half. I guess it just needs... Oh, well, broke something. Oh, I have to pass the name. Okay. If I take out the plus a half, it looks the same actually. Guess I should just take that out. Angle divided by 2 pi. This is going to slow down the rotation. That's probably good. You just output this. Okay. Angle radius. I wonder what happens if you... It's passing angle radius 1. What if you did just x, y, 1? So it's passing angle radius 1. What if you did just x, y, 1? So like 2 center dot x, 2 center dot y. Well, that looks pretty terrible. I did y. I want to do +1. That looks a little better. I did 1.5 or so. Okay, okay. This is like taking hue saturation. I think that should be a V, hue saturation value, and bring that to RGB. But okay. Shader base. I think a good one to do would be... I think the vertex shader would actually be a good thing to cover first. So I'll keep that in my pocket for the fragment shader. I'll call this like fragment shader example or something. I'm exposing those parameters in the UI. I'm not exposing anything in the UI right now. Basically just the scene. Eventually, I will start exposing things in the UI to make them more interactive. But with that, wherever I ran that, now I can run the thing from the tutorial. Example graph, don't need that. It should be called fragment shader example. And it wasn't found. So I have to change this. Great. But before that, I want to do an example with the vertex shader. And so the question becomes, what cool thing can I do with a vertex shader? That's like fairly simple. So let me just run vertex shader example. Oh, that did something wrong, I guess. Oh, it just doesn't do interactive embed. Okay, so what I could do, I think it'd be sort of interesting to do like a sphere, but the sphere would be composed of dots, maybe? So, let me see. Maybe just moving squares like in a circle would be enough. Maybe that's all I want to do. Because I could pass to something like angle, and then it could be just angle alone, I think. I just pass these an angle. Well, it would have to draw a triangle. So how do I get triangles in the right shape? I think maybe... Okay, let me try this. Def like generate square. And it'll have to have like an X and Y coordinate. And this should output points similar to these. So not -1, -1, 0. But, okay, how do I want to organize this? A shape like this. So this is the top left corner. Then I can do -1, -1, 0. I want to organize this. A shape like this. So this is the top left corner. Then I can do -1, -1, 0. +1, +1, 0. And then +1, -1, 0. A shape like this is not a square. It's a rectangle. And I'll up the number of points. Oh, this is the dimension. Why not the 3B1B logo? That would be too complicated. Unfortunately, that would be cool. But I could take this, and if I divided these, if I took this and I divided it, by the width and the height of the screen, then it should become a square. So if I said attributes at position, all rows, 0th column, divide equals 854. Why did that not change anything? And with the texture, oh yeah, with the texture it wouldn't be so hard. But getting into textures would be its own beast. Comma. Okay, there. So I did this by 854. This would make it 1 pixel, which is too thin. If I did this, a 1, I divided this by, what was it, 480? Okay, so now it's 1 pixel, which isn't what I want. However, this gives me a starting point for what I'd like to do. So let me take position. First of all, let me do this in the vertex shader. So I can do position dot xy. Okay, it's position dot x equals position dot x divided by 854. And the y divided by 480. And I won't do it here. And if I run this, it actually looks like nothing appeared. Do I need 0.0 here? Still looks like nothing appeared. I feel like this is the life I get to look forward to with shader programming. Assignment to varying position. Okay, guess you can't do that. I'm gonna try rerunning this. I get the pixel. You probably can't see it, it's really small. I'll say vec3 normalized equals, I can say vec3 position.x divided by, I'll say 8 by 4, position.y divided by 480, 0. Yeah, and then I'll replace this with normalized. And I won't do the division here. And it still disappeared. Oh, I think I need the semicolon. There, it's back. Okay. So now I drew a 1 pixel thing. But I don't want it to be 1 pixel. So if I just multiply this by something, so I just made this like 10 times this, and 10 times that. Now it's, so I just made this like 10 times this, and 10 times that. Now it's 10 by 10 pixels, which is great. So this needs a few parameters. It needs the width of the screen, the height of the screen, then the size and pixels that I want this thing to be. So you pass in a uniform, vec2 resolution. And let me see if I can do vec3 normalized. If I can put this here, I think it'd be a little clearer if I could say normalized.x equals position at x divided by the resolution thing. So I'll say 854. Normalized.y equals this. And z will just default to 0, but maybe I'll just write it out. So this should do the exact same thing. Oh, we'll have to multiply it. Exact same thing. So now, what I'd like to do is pass this in as a uniform. So I have these position coordinates. Now let me pass in a uniform. So I can say, there's the shader object. Shader.setUniform. Resolution. And this is like config at something. I think this is like frame width and frame height. Hope those are right, because I'm just gonna check them like this. So I'm gonna resolution.x. It didn't work. Okay, this would be frame. Is it like pixel width or something? That didn't work either. And it crashed something. It just didn't exist, frame pixel width. Hard code some numbers in. Well, yeah, maybe I could do that. This isn't actually that hard. I just don't know what the name of the variable is. But I should be able to find it. Hopefully. Config, is it config init? No, that's the same thing I opened before. I think you might have been right. Oh, it's pixel height. pixel width. Okay, now it's back. Frame width is 14.2. Yeah, that's what it ended up being. Okay, so now I can divide by resolution.x and resolution.y. I wonder... Okay, wait, one more thing. Then let me get the size. Like squares dot size. Which will be a int 32. Broke something. Is int 32 a real thing? I should probably learn OpenGL one day. It is. I don't know. It's bool. It's int, which defaults to 32. And uint. It's bool. It's int, which defaults to 32. And uint. Okay, so that brought it back. Now I can pass in the dot size like so. I'll pass this in. Change around. Oh my gosh, my shortcuts are still... I should stop changing my Vim configuration so much. So now I should be able to increase the size just by increasing this. Oh, and I have to actually do that. Perfect. Great. It's all coming together. I wonder if I can say normalize.xy. I wonder if I can like vectorize this. That's convenient. Then the z will default to 0. So that's great. What I want to do now, though, if I'm gonna make it go in a circle or something, I'm gonna have to have the time. Maybe here's what I'll do. I'll pass in another attribute, which will be the angle. So I have position. This is just gonna trace out the square. Then the angle is gonna be an angle at which to translate the square. So for this, for these, let me just put it at pi/2. I'll do that for all of these. Okay, so then I'll have to add the extra attribute here. Even for a relatively shader, this is ending up being relatively detailed. Don't do Conway's Game of Life. I'll do my best. Okay, so now it says 6, a position and an angle. I'm passing in the position and the angle. Great. In vec3 position in float angle. This actually still won't work since it's optimized out. So I have to use that. So I have the normalized. What I want to do is normalized plus equals. I think you can use plus equals. Then I'm going to add like a vector, which will be like R angle. And R will be hard-coded, it'll be like 4. But like, how do I convert this to Cartesian? I know I should remember this. Isn't it like... Okay, now I'm gonna try to remember my math. Bear with me. You have R theta. And you go x equals R cosine theta. Y equals R sine theta. There's no z, and z will stay, and so that's just what you do. Cool, so I'm gonna say displacement has to be a vec3, I think. Displacement is gonna be vec3. It's gonna be, I'll just call it 5, maybe 4, multiplied by, I'll just put cosine angle. And I'll just pray to God that cosine is a OpenGL function.